going to be our YouTuber for today.
Inside New York City's richest suburbs.
100
Let's see. Put that right there.
$1 million mansions,
This is our YouTuber for
Lamborghini
today.
dealers, secretive billionaires.
Yeah.
An hour outside New York City in southwestern Connecticut are two towns that are among the richest in the world. In this video, we explore these places to understand how they became so rich.
It's because Greenwich as well. Yeah, they have like all of New York. Like all of New York rich people just live in Connecticut.
We are currently in one of the wealthiest suburbs of New York City, Old Greenwich, Connecticut.
Why is it called Greenwich if it's Greenwich? Silent W?
Median home price here is $3.5 million. Our first stop, Greenwich, Connecticut, is home to more billionaires than the United Arab Emirates.
What? The UAE has less billionaires than the city of Greenwich, Connecticut?
Greenwich, Connecticut is home to more billionaires than the United Arab Emirates. The reason is because of hedge funds, a shady and controversial industry that we explore later in this video. We took the train from New York to Greenwich, and immediately we saw...
Do you think the kids that grow up there are humble or like assholes? I think...
Look at
What's up? We're with Duolingo. My Duolingo, it's already done. I'm gonna have a freak out. That's not there. Okay, this is like that. Put that right there. And this is a box. And in the box, you have a tube. And in the tube, we have something. And okay, so that's a box. And then you have something else, which is more box. So on the bottom of the box, if we could find a way to make it like this. We need a box to be like this, and this, and we need to pause the video. What's up again? Maybe if I do this.
your inventory. Do you have any
Cool.
like
That's great.
wood?
I got
Also,
3 wood.
make sure you
Put it
grab
right
these
here.
items.
Wait,
by the
no,
way,
I actually don't
the
think I
ones
have
I
wood.
just dropped.
Oh,
Okay.
thank you.
So we're gonna have to go outside, and you're gonna have to
Stay
chop wood, and I'm gonna teach you. I'm
Go
gonna
here.
teach you how to work this
Okay.
game. All right.
Okay.
Yeah.
How do I get? I have
So the
craft
thing
wood
is
and
with this
planks. The
is
recipe
that
book
we need to
can
first
help.
pause this video and maybe put it back. Just gonna put it there, and then we need to do that, and we need to do this. This is a 3-prong tube, and it has to be fire resistant, and this is where air would go. Now, what we need to know is that we need to do some calculations, but I think we can finish this first, because why not? It's fun. Okay. Right here, right here. Right here, right here, right here, and this right here, and put that right there, and yeah, okay. So it looks like a candle holder, but it blows oxygen into the place, and these lines are so poor. It makes every art teacher sad and want to cry. So don't do that. Don't make your art teacher cry. Mi maestro. Muy cansado. Okay. So that's the important thing right there. And what we need to learn is fire knowledge. We need to know temp of plastic. And we will have a short break. We're back. Temp of plastic. Now, the way this was described, it had a chart from 0 Celsius to 400 Celsius. And you can have this chart, right? And this chart can be a super chart, right? Very chart-alike. And so what if we got it up to 400 degrees? Because 400 degrees is something interesting and useful. And so we got it there. And that's, oh no, that's 400 degrees, and that's stuff like that. That's great, amazing, awesome, right? That's what we think in Fahrenheit. 200 degrees Celsius. Okay, and this is maybe where you have some condensable chains. Come on. Put that there. Okay, and yeah, that's that. That means it would condense. That's better, I guess. You have condensable chains. So that's probably where you want to get that plastic. So that's 400 degrees Fahrenheit, what we usually know. Now let's look for the video, because the videos equals answers. And then, yeah, so we're gonna, I could just get it now. Let's see. Let's see.
Hi everybody, so in video 17
videos equals
or 7, we looked at pyrolysis.
Let's see, we gotta go here. We never got past that, which is a little statement right there. There's another one for that. Yeah, there was that. Okay, for that. Okay. Yeah. This one.
Things that happen is that any light boiling off product and they can do that. It's called.
This one.
When you do that, a couple of things
Let's see.
happen. The first things that happen in 7, we looked at pyrolysis. Pyrolysis is where you heat something in the absence of oxygen.
Come on, stop.
When
pause.
you do that, a couple
Pause.
of things happen. This is where you heat something.
Okay, let's see. Full screen. We can't remove it. Moisture, just removal, dehydration. 200 degrees Celsius. Helisola compadisol. What the biogas, biochar. Lignin bio oil char. So it looks like if we get to that, that will work. Okay. Let's see. So this is that, and it says like around 300 lignin decomposition bio oil biochar, which is we want to oil, cellulose decomposition, synthetic gas, bio oil, minor biochar, which is we want oil. We want a crude oil. Let's see. Where's it? Come on, press that thing. Work. Want oil. So if you want crude oil, then you have to get around 240 degrees Celsius to, 500 degrees Celsius. And then, so if we want to learn something about that, then we have to find out what it's actually talking about.
In the absence of oxygen. When you do that, a couple of things happen. The first things that happen is that any lightweight stuff in there boils off. The second thing that happens is it can break down. Now, in 1710, we looked at that boiling off process. So in 1707, we just turned it all into gas and lit it. In 1710, we made sure that the liquids could go back to being a liquid, and they created as methanol because we used oak. This is what does that. This is a condenser coil. It's hanging out in the air and it's cold. The hot gas comes, any liquid will then condense and drip into a container. Now, the scientific method is pyrolysis. That's what we're actually doing. But when we put it in a specific example like this, and we do that, it's called dry distillation. So we...
Okay, so we want to get around at least 600, and because I think that's the middle. That's not middle, this is the middle. And because it's the middle, you got you've got that, and you've got that. And that's 698 degrees Fahrenheit, which is about the middle of that, which is 370 Celsius, which is the middle of 200 and 500 degrees Celsius. Now, with that being said, we need to learn how hot can a fire get. Average temp of fire. What is... We're going to take this chart, if we can. Come on. And we're going to copy, and we're going to try to paste. But we can't paste. Okay. We don't need the chart on there. It's fine. Just visible. Dazzling white. Just visible is... this 525 degrees Celsius, which is like 1,000 degrees Fahrenheit. But, this is going to be inside of a tube. It's going to be inside of a tube. So we need to look at the conditions inside of this tube, because you have stuff like heat transfer and all of that. And we'll put this is where the vapors huff and smoke. That's where the vapors come off. And with that being said, we'll need to look at the conditions inside of the tube. Okay, so we're back, and yeah. La 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 la. I am stronger. Yeah. That's so cringe. The inner conditions of the tube look something along these lines. Put that right there, that right there, this right there. No, we're probably gonna apply heat if I could get this right. Heat to this. Energy, force maybe. Okay, so yeah, we apply heat to that and then it's all great, right? And we apply an upper flame, which is something like this. It goes like this, like that, and let's see, we go like that, and like that, and yeah, that's gonna be the flame, and that's the flame. Lovely. Lovely, lovely, lovely. Okay, so yeah, let's see. We got the flame, and then the inner conditions of the tube is equal to metal times heat times area plastic flame, and we think means is that you have a X heat transfer, and then it will get so hot. It will get so hot. It will get 5 to 5 degrees C. That will be so hot, and then it will be so hot in the chamber that it will start to vaporize and fill up the container. And because it does that, it will vaporize and vaporize and vaporize. So that's the metal. The metal is almost 100%. Almost. We don't know for certain. We're probably guessing this. And then we have the heat, that will be really effective. It will be really effective because this will be in there for a while. It will be there and for a while because it'll have time times time. You can't have it square. You can have it squared. Time is, well, that would be, you multiply it and you would get an area, and that would be the amount of thing you would have, but you wouldn't multiply heat times heat. But it would get hot enough to that, and then affect the area, so it would get hot, and then the plastic would start melting, and then the vapors would be so steamy hot that they would start melting more plastic vapors and making it in there, and making the vapors inside of it. So that would equal vapor. And to get these vapors, we now need to go back to logic. Does logic, like Google knows logic? Then we put the Wi-Fi on. We put the Wi-Fi on. We put the Wi-Fi on, and then, come on, please work. Okay. That looks like a really old video because it's 3 years old, and I just got a notification. So 300 to and plastic converted. Okay, here's the thing. is that metal hydrovertic converter with platinum and woozy and xenolite, whatever, is something. And then they got 300 hydrolysis, some sort of catalyst, pyrolysis, hydroforming. All of it seem high temperature pyrolysis, thermal catalytic. Well, this is not doing much because it's not saying oil, it's hydrolysis, which is to split the hydrogens off of it. Hydroforming, which it would make new stuff. And then high temperature pyrolysis is just to break down. Pyrolysis. This is hydrolysis. Hydrolysis, to get rid of it, melt hydrolysis, would just be burning off the stuff. One second. Okay, so we got the 800 degrees between 400 and 500, 450 degrees Celsius is equivalent to around 700 degrees in Fahrenheit, and then 842 degrees Fahrenheit, which I believe we will we will reach that, excuse me, that's okay. So now that we got that in place, that is a check because we got the heat, but it might heat it up to a non-liquid form, but we can also just cool the flame down by reducing the oxygen content inside the flame firebox. And with that being said, so we got the firebox and we got that. So now we need to decide a general structure on how this could work. It don't need to be bougie. It just need to be worky. So what that does is we're gonna go back to the firebox, and I believe it was all the way back here. Over that's the firebox, and then that this is bougie. And yeah, so then we got that, and then okay, so now we go back to the fire box, and now we're gonna see what we can do with that, because we need to get something like this, when you get something like this, and when you get something like this, and then we need to pause. So now that we got that, we're gonna get this down like this, and this down goes like this, and over here goes like this, and now it's like totally off base, but whatever they said whatever. Okay, and let's see. So what we want to be able to do is just, come on, have this as a box. Yeah. So that means that we have this right here as the box, and then so with the box is gonna do, we're gonna have some things. We're gonna have a hole. Let's see. We're gonna have a hole here. Then we're gonna have something there, and then we're gonna go over here, and we're gonna have a hole here, and these holes are not gonna be as big as that, because no possible way, there's no way. And then we're gonna have it not there, and I'm gonna delete that. Nope, not that. Do that. And then over here, we're going to have this ruler line thing. If I could just get it to work. If I could get this thing to pull over here. Right here. And then we'll have to go down. Come on. Let's see, right here. Put this right here. Let's see, right here. That's us. Yep, that's us. Lovely, okay. So we go over here again, and we find that we need another hole through here, and we go over here. Excuse me, put that right there, and we need another hole right here. Okay, so that's great. So got that down. That's lovely. Okay, we got a box. We have air. We have air rush here. And we have air rush here. And then heats up. And then it goes here. And then it goes here. So we need to look at the general format again. What we need is a tray that goes here, way across this, and maybe I should use that. 1 second, because I can't pause this. If I could pause this, I would pause this. Yeah, we got that down. Lovely. Okay, so we got everything all up in this contraption, and it's very contraption-like. But the thing is that we have an airport down here, and do that again, and then do this, and do that, and do that, and this, like here. Sure. If I could get it to run right. Okay, we got that down there. this down here and that down there, and this is the airport. Now the thing is that with this thing, we need to blow air into it. It's going to be smoky if not, and that will work like this. So we will. Okay, and so the way that will work is we'll take a ruler like this, and everything is slanted, which is kind of a problem. We need it to not be slanted. Go back over here. No, that's not right either. Do that. That's better. I guess it works. Go like that and like that. Okay, so that is like that, and then the thing is that we have our little contraption that you saw in the shorts, and it will put air into here. So we'll have a container here and here, and we can have a little device right here that allows less or more air in, and that will be run by a little power thingy, wall outlet thing there, and then that will blow air, and we'll take air from here and all around here, and it will blow the air inside of here, and then so we'll have the air travel through here, then it'll go up. This is where the feed is, where we put our solid fuels, and if you can't see that very well, we can bring, you probably can see it. So we need some sort of like tray. We can have these little stools that sit right here, and it can have like some sort of basket over here, and just have this basket run along here like that, and then we can have it go here, 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 and you can have all that. You can have all that. Okay, 1 second. I think I got the brush. Okay, and then you have this basket which holds all the fuel, and we need a certain fuel. We need lasting fuel. But to do that, we would need some sort of, we can have a tower, a feed tower with a silo. We can have a silo, a Shiloh, and go like that, and it can go like that, and here, right here, put that right there. You can have the feed tower. You can have it go up, and then, we can have it like here. And then, you can have like a shredder here, and then it just shreds cardboard. You got like one piece, you got like, the one piece, and you just get your arms reachy uppy, and then you use your legs to stand on the ground, and that will be the tower. You can have it like that, and over here like this, like that, like that, like that, like this. Okay, and then everything can be fed into a hopper and go here. And then you can have it go be put into here, and that would be something. Or you can change the feed mechanism. I'm gonna be back. So we're back, but we're also not. So again, yeah, we're back. And that's that. Okay, so all of that works together like that, and that would be something. Or you could have it being blown, the fuel being blown, solid fuels such as cardboard being blown in with the airflow. You got that there, which is rush, 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 air, air, air. And then you have solid fuels being blown in. So now you have a mixture of air and solid fuels being going there, and that's would be fed into the pipe. And then, you know, you would start your flame. You would have your flame start in the container in here, and we'll make it average. We'll make it the average size for that reasons and sakes, and then we'll go here, and you'll have the perfect air mixture and the perfect fuel mixture, and then you can have a spark, zap, fire, and you can burn it there, and then that will start it up, and then, you know, it will exit out here, and that will be great. And then you will have airflows here, intake, and then you can have it here, the pipe like that. So container is the there. So we have to look on how are we actually going to construct? How are vamos we going to construct this? And the answer is we're going to look at the box. We're going to look at the box and see what we have. Okay, and this will be our list. What does this look like? That's a real animation right there. Okay, so we have all of that. We have all of that. We have all that. And yeah, and then we got that, and then we have a drill, and we have a container, and we have all of it, and we have somewhat of an airflow, so we can put it all together. Put together in real life. Okay, we're good. And with that being said, we are good to go. So yeah, thank you. And 2 and 1. Yep. We gotta not rocket ship it, and we gotta go here, and we gotta go like that, and then we gotta go. Yeah, look at all that. Look at all that, man. Right. And then, yeah.